Common logarithmic rules. There are three basic rules. There's the product of sum, and it looks like this. If we take the log of any base of a product, say x times y, well, that it's broken up into log base a of x plus log base a of y. So we're going from a product to a sum. The second rule is a quotient to a difference. In math, quotient means divide. So when we're dividing two things in the domain, that actually becomes subtraction. Minus log base a of y. So you can see they're kind of similar. When we multiply, we add. When we divide, we subtract. The third rule that we're going to talk about today is the power, the product. Product again means multiply, quotient means divide, sum means to add, and difference means to subtract. The rule says if we have a log of a base of something raised to a power, let's make that a b, then that's going to be that exponent comes down in front and gets multiplied times log base a of x. So you can see this sort of comes down in front, as it were. Let's start with the first rule. Log base a of x times y equals log base a of x plus log base a of y. We'll start with an example. Let's take log base 3 of 2 times x, or 2x. If we want to break that down, we need to recognize that 2x is actually 2 times x, as I mentioned. This will become log base 3 of 2 plus log base 3 of x. So you can see we actually broke this down into a couple of different pieces here. Let's do another example. Log, we'll call this one the common log. Notice there's no base written here. That means it's actually base 10 of x squared y. Again, we need to recognize this as x squared times y. So this will be the common log of x squared plus the common log of y. We went from a product to a sum. A third example, we'll say log base 7. Maybe we're talking days in a week, so it's base 7. 5, x to the 4th, and we'll get kind of weird here, and we'll say this is a happy face. Well, now I have three things multiplied. I have a 5, I have an x to the 4th, and I have a happy face. So in this case, it's going to break up into 3 individual pieces. Plus log base 7 of happy face. Now, if there were 4 pieces, then we would break it up into 4 separate logarithms. If there were 10 different pieces, then we would break them up into 10 different products, I should say. Then they would break up into 10 different logs. Let's talk about the quotient to difference rule. That's the rule. I'll block that off there. This is log base a of x over y breaks down to log base a of x, now minus log base a of y. So when we're dividing, it turns it into 2 separate logarithms that are subtraction. Let's do an example. Here we have log base 5 of 4 over m. Well, just like the rule says, this will become log base 5 of 4 minus log base 5 of m. What we can do now is we can actually combine up a couple of rules that we've already used. Let's take log base 17 of x squared over y z to the third. Now you'll notice I have two things in the denominator in this case. I have a base y and I have a base z, which is raised to the third power. The general rule is, if it's in the denominator, it's going to have a minus in front of it. So this will break down into log base 17 of x squared minus log base 17 of y z to the third. Now we got to be extra careful because inside this log base 17, I now have a product. Now it could be a little confusing, so I'm going to carefully rewrite the first part, log base 17 of x squared minus, and I'm going to put a bracket here. Now I'm going to use the previous rule, the product of sum rule, and I'm going to write log base 17 of y plus log base 17 of z to the third. However, you'll notice I have to distribute the negative, or the negative 1, to both pieces to give me an answer of log base 17 of x squared minus log base 17 of y minus log base 17 of z to the third power. And you'll note that I have subtraction for both the y base as well as the z base. I have a positive log base 17 of x squared minus log base 17 of y minus log base 17 of z to the third. We're going to do one more example. This one's a little long, but it again combines up both rules. We'll use the common log again, base 10. Up top I have 2 x to the third. Down below I'm going to have 5 y to the fifth times the square root of z. Now I'm going to notice that I have 5 bases here. I have base 2, base x, base 5, base y, and base z. All of the bases in the denominator, the 5, the y, and the z, are going to have a subtract with them. So here we go. Log base 10 of 2 plus common log of x to the third minus common log of 5 minus common log of y to the fifth minus common log of the square root of z. A lot going on there. Notice I have 3 minuses here because there are 3 bases in the denominator. Let's move on to the last rule, the power to product rule. Power to product is going to be log base a of x to the b power equals b, the exponent, times log base a of x. And we're going to go through quite a few examples of these, and we're going to combine up the previous rules as well. Our first example will be a nice simple one. Log base 3 of 7 to the 4th power. The exponent in this case is 4, so the 4 actually is going to come out in front and be multiplied to what's left. And that's all we have. Next example. We're going to go log base 13 of the square root of x. Now if you think back to your exponent rules, square root of x actually is an exponent. If you remember, root x means x raised to the 1/2 power. Now we can apply the rule and bring the 1/2 down in front. And there we have it. Remember, on square root, it doesn't show us what the denominator is for the exponent, but we should know that it's a 2. Alright, so this next base that we're going to have is base e. It's that weird number 2.7 and change e. And we actually have another way of writing it, which I will rewrite here in just a moment. So we're going to have log base e of 1 over the cubed root of m to the 5th power. And instead of writing log base e, I'm going to write the natural log. Of 1 over m to the 5/3 power. You should recall these exponent rules from a previous chapter. This becomes the natural log of m to the negative 5/3 power. That's one of our exponent rules. If we move it from the denominator to the numerator, it changes the sign of the exponent. So natural log of m raised to the 5/3 power, using the rule above, I'm going to rewrite this as negative 5/3 natural log of m. So that one's a little far-fetched, and we're going to even take it a step further. So you're going to have to go back and review probably some of your rules that have to do with exponents, including the new rule from intermediate algebra with the rational exponents. Our next example, we're going to use the common log. And this is x plus 4 raised to the 3rd power. Now the exponent in this case, of course, I can't give that straight up to the x and to the 4. I would have to FOIL all of that out, but we're going to save a little work, and I'm going to use the rule above, and we're going to get 3 times the common log of x plus 4. Now that is my final answer. I am done there. I want to make sure I don't try to do something crazy like distribute the log symbol and make it log of x plus log of 4 or something like that. That, of course, does not work. We just need to keep it as is. This is done. We can't go any further with this. Even in higher level math classes, we can't. It stays exactly like that. All right, we're going to do one last big crazy example. So here we go. Log base 9. Here we go. Of 12. Parenthesis, x squared plus 2x minus 5, all raised to the 7th power, divided by m to the 4th power times the 4th root of y. Now I'm going to notice in the numerator, I have a 12 times x squared plus 2x minus 5. So those are two bases. That x squared plus 2x minus 5, I just need to view that that's one big base raised to the 7th power. Down below, so I'm going to have minuses in front of them, I have base m to the 4th power, and kind of hidden in there is base y raised to the 1/4 power. So here we go. Log base 9 of 12 plus log base 9 of x squared plus 2x minus 5 raised to the 7th power minus log base 9 m to the 4th. Again, minus, remember the y is in the denominator, log base 9, and I'm going to write that as y to the 1/4 power, so we can directly see that. So next up, I'm going to use the power to product rule, and all the exponents are going to come down. Log base 9 of 12. I could split 12 up into 2 times 2 times 3 and break that down further, but we're going to leave it as it is for now. Plus, I'm going to bring the 7 down times log base 9 of x squared plus 2x minus 5 minus, I'm now going to bring the 4 down with the m, 4 log base 9 of m, and with the y I'm going to bring minus 1/4 down. That'll be log base a of y. And that is as broken down as we can make that for right now. Again, make sure you don't try to do something wacky here and distribute the log base 9 into the x squared and all that kind of stuff. It just stays exactly like it is. And that's that.